Hello everybody. I welcome back to the C programming session. In the last session, we had gone through the single dimensional arrays and also some of the examples with respect to the single dimensional arrays. The most commonly or important programming part while we are dealing with arrays are searching and sorting. So one of the examples that we took was searching, that too by making use of the linear search technique. And in today's session, we will just look into one of the sorting techniques. Of course, we have several sorting techniques, out of which one simple sorting technique is the bubble sort. So let us have a closer look at what sorting is and how this bubble sort technique functions. Okay, let's see what sorting is. Sorting takes an unordered collection of elements, and after applying the sorting technique, we will order them into either ascending order or descending order. So as you are seeing, you are looking into 6 elements over here, in which it is just an unordered collection of numbers, and after the sorting technique has been applied, the result would be that the elements are sorted in an ascending order. So in order to achieve this, we are going to make use of the bubble sort technique. So what is this bubble sort technique? Yes, we start the comparison between two elements, that is the first and the second element, and if they seem to be out of order, we make an exchange between these two elements. So there, we are comparing 77 with 42, and if it happens to be out of order, then we swap the elements so that it is exchanged. So this keeps happening every time. So the first and second and the third and the fourth, etc. So you see this in this animated picture, that we do the comparisons with each and every element. So there it needs a swap and it has been swapped, and again between the third and fourth it needs a swap. So the elements are swapped. So this carries on until the until the element, that is which is the highest element, will be placed in its final value. So as you see, you are seeing among these elements 101 remains to be the highest element. So that is being placed in its final value after one iteration or after one pass, that is after making the comparison of all the elements in the list. So here as you see, the number of passes or the number of iterations that are required in order to achieve this final output would be n minus 1, where n is the maximum number of elements that we have taken. And as you see, we can also reduce the number of comparisons in the list, that is, while we have taken 6 elements at the beginning, in the next iteration we would be making just 5 comparisons, because we know that the 6th element, which is the largest element, will be put in its final position. So in the next iteration, that is in the third iteration, we will be making minus 1, that is 4 comparisons as against the 6 comparisons in the earlier stage. So like this, at each iteration or at each pass, we are reducing the number of comparisons too. So at the final stage, that is on the nth bubble up, that is the nth iteration, we are going to have just the 2 comparisons. Now suppose in between, if the elements happen to be in a complete sorted manner after say the second or the third iteration, then do we need to carry on till the n minus 1 iterations? It is not required. So, how do we reduce the number of iterations in case the array is already sorted? So, we are going to make use of a boolean flag variable, where we are going to set this flag variable either to a 0 or 1, and then on making comparisons, if we have not swapped any element in a particular pass or iteration, then we are going to set this flag to 1. So, earlier if we have taken it as 0, we will be making it a 1 right now. So, just look at this example. We have a flag variable and we have set of elements like this, and we are making the comparison. So, we are comparing the first with the second element, 98 with 23. So, here we are arranging these elements in an ascending order. So, as we know, it requires a swap over here. So, when we swap, it becomes 23 and 98, and the flag variable simultaneously changes its value from false to true. So, in this particular iteration, we are not bothered about any other flag variable. Either it is going to be changed or remain unchanged. Since we have already made a swap, we are going to proceed with the next iteration. So, this carries on while the comparison is happening. So, every time your flag variable remains to be true because the first time it has already been made true. So, that is the end of first iteration. So, after the first iteration, since we have swapped, that is flag is true, we will continue with the next iteration wherein we are not going to consider the last element. So, it is going to be n minus 1 element to be compared. So, for this, let us just have a look at the program example. In the last class, last two sessions, we have already discussed how we are going to declare an array. So, here I am using an array called A with maximum of 30 elements, and I am inputting the values for that array where the maximum number of elements is n. So, I read the value for the array, that is scanf ampersand A of I will input all the elements till the maximum limit, and then I am printing the value of all the array elements once, that is the unsorted elements are printed once. After that, based on the algorithm whatever we have discussed till now about the bubble sort, we are having the loop iteration. The first for loop indicates the number of iterations that we are going to handle. So, the maximum, that is in the worst case, the number of iterations will be n minus 1 iterations or n minus 1 passes. And in case the swap is not taken place in certain iterations, then we are going to just come out of the for loop, that is it is going to be lesser than n minus 1 iterations. So, here we have a flag variable to keep track about how many iterations are required, and this max is a variable which is going to reduce the number of comparisons at each iteration. So, as I told you, the largest element is going to be put in its final position. You need not consider that final position or the other positions at each iterations for the next comparisons. So, that is why we are going to reduce the number of comparisons by making use of a variable called max. So, here in your inner for loop, we are saying from j is equal to 0 to max, that is till that n minus 1 or n minus 2, n minus 3 etc. as and when the higher elements are put in its final positions, we are going to reduce that. And we are comparing whether the first and the second element are in order, that is if it requires a swap or not. If the first element is greater than the second element, then it needs a swap. So, the comparison is made. If that is the case, then we are swapping. So, these three statements what you see are required to swap the two elements. So, I make use of a temporary variable over here, where I am assigning the first element to this temporary variable and the second element to the first element. This has to be done because the value of the first element would be lost if I do this statement directly. So, that is why I store my first element value into a temporary variable and then I assign my second element to the first element's position and then the temporary variable back to the second element's position. So, that way we have made a change between the first and the second element. So, this I am explaining it only for the first and second element. This happens for any number of elements, that is the second, third, the third, fourth etc. And then as we have swapped the elements, I am changing the value of my flag to 1, that is my boolean variable to keep track of the to stop the iteration. So, now I am changing it to 1 since we have made a swap, and after that I am trying to print the which pass is that and then what is the status of my array elements currently. So, each time at each iteration or at each pass I am trying to print the array result, and finally I am also checking if this flag variable has been a 0, that is if there are no changes that have been made in the iteration. If there are no changes, then I am going to stop the iteration. If there are any changes that were made in this particular iteration, then I am going to continue with the next iteration. So, let us see the output of this program. Say I enter the number of elements as 5. So, I need to enter all my 5 elements. So, there we have 5 elements, and this is the worst case because the array is in such an unordered manner. So, it has taken 5 minus 1 passes, that is 4 passes, and at each pass you are able to see the status of the array. So, at the end of the first pass or the iteration, you have ended up with these values. So, as you see in the third pass also we have made a change. Since there was a swap over here, we are going to continue with the next pass. So, that is about the bubble sort technique. Now, next coming to a multidimensional array. A multidimensional array is nothing but a set of single dimensional arrays. It could be a 2 by 2 or a 2 by 3 or a 3 by 3, 4 by 4 etc. So, here we are not concerned about any higher level of multidimensional array except for a 2-dimensional array. So, a 2-dimensional array is nothing but it is a simplest form of a multidimensional array, wherein This two-dimensional array can be told as a list of one-dimensional arrays, and it consists of both rows and columns. So, the simplest example that we can quote for a two-dimensional array is a matrix, which consists of both rows and columns. And to declare a two-dimensional array, we need to have the variable name along with two square brackets in which the values of the rows and columns are being specified. So, within the two square brackets, we are going to specify the number of rows in the first bracket and the number of columns in the second bracket. So, as in the example you see, you have a two-dimensional array called vals, which is of type integer, and you have two subscripts over here or two indices. So, the first subscript specifies the number of rows. So, here your vals array has 3 rows, and the second subscript indicates the number of columns. So, the vals array has 4 columns. So, it means that it is a matrix of 3 by 4 order. Consider this matrix A, which consists of these elements. So, this is a 3 cross 3 matrix, meaning that it has 3 rows and 3 columns. And the elements of this matrix or array is going to be accessed by making use of, that is, A, M, N, where M and N are enclosed by the square brackets. So, whenever you want to access, say, the first element of the array, since it belongs to the 0th row and the 0th column, we know that in C we always start our array from the 0th location. So, now even in case of a two-dimensional array, we are talking about the 0th element. So, here it is the 0th row and the 0th column. So, when you say A 0, 0, it means that we are talking about the first element of the array. When we say A 0, 1, we are talking about the first row, second element of the array, and so on it goes. So, in C programming, the array elements have to be represented in this manner. Suppose we have an array called A, I am going to access or refer to the first element of the two-dimensional array as A 0, 0, both enclosed in square brackets individually. So, when I say A 2, 2, it means that I am referring to the array element which belongs to the second row and second column. Assume that we have a matrix called val, which consists of 3 rows and 4 columns. So, here this is the matrix and we have 3 rows starting from 0, 1 and 2 and columns 0, 1, 2 and 3, that is 4 columns. So, if you want to access this particular element in your array, what is the address or how are you going to access through our array subscripts? We are going to call it through the matrix name or the array name, which happens to be val, and since the value 9 is located at 0th row, it is val 0 and 2. So, it belongs to the 0th row and the second column. So, to access the cell containing 6 over here, we are going to address it through val 1, 3. How are these two-dimensional arrays used in the C programming? that is how are the elements in these arrays accessed or referenced. They are used in a normal manner, that is as any other variable we are going to reference these array elements too, except that since they belong to a two-dimensional array data type, we need to add those two subscripts along with the array name. So, here say for example, you want to find out the sum of the first row elements of the matrix or the two-dimensional array VAL. So, what do? We are going to access each and every element of the array by saying the subscripts. So, here as you see, you have val 0, 0, which means that it is the first row, first column element. So, as we are referencing only to the first row elements, as you see, the first subscript of all these variables in this expression are 0, which means that it is the first row element. And since we are referring to different columns, so the column subscript over here, that is the second subscript in this array, keeps changing until how many ever columns we have in the array. So, this keeps changing 0, 1, 2 and 3. So, that way a two-dimensional array elements can be accessed just like an ordinary variable, except that along with the variable name we are going to add the subscripts with it. And suppose I want to assign a value to a particular array element location. So, that I am going to make use of an ordinary assignment statement, and again I am going to use the the subscripts along with the array name. So, here if I say val 2 3 is equal to 72, it means that in my previous example, that is val 2 3 is nothing but 2 and 3, that is this element's place. So, this location will be assigned with a new value, that is 72. We saw different ways of initializing a single dimensional array. The same way, the two-dimensional array also can be initialized in different ways. Initialization of 2D arrays, or while we are assigning values to the two-dimensional arrays, this is going to take place generally in the row order. So, the first row elements will be taken first, followed with the second row elements and so on. So, these are the different ways that we can initialize the array variables. As you see, int val 3, 4, that is you have 3 rows and 4 columns array called val, wherein I am giving the values as 8, 16, 9, 52, that is 4 columns, and this is the first row, and this happens to be the second row again with 4 values, and this happens to be the third row again with 4 values. As you see, each row element we have enclosed within a separate flower brace like this, which I am saying that these are the first row elements and these are the second row elements, and this happens to be the third row elements. As you see, all these elements are separated by commas, and after the first row element again it has been separated by a comma, that is after each row elements. So, there ends the initialization of the two-dimensional array. Is it mandatory or is it compulsory that we need to separate each of these row elements by having a separate flower braces like this? Need not be. You can skip this flower parenthesis like this and simply say the array elements such as this one. Here we are trying to differentiate the different rows by putting them in different lines. So, this happens to be your first row array elements, the second row array elements and the third row array elements. And as you see in the third example, we have not even brought them into different lines. All the values have been declared on the same line. So, here as you have a 3 by 4 matrix, the maximum value that we can give for this is 3 into 4, that is 12 values. So, if we are assigning with all these 12 values over here, then they would be taken in the first row 4 values would be taken and in the second row 4 values would be taken, so on. So, that way we could initialize the values of a 2-dimensional array. We will just see the difference, what happens or what is the advantage of specifying braces after each row element later. Suppose we are not giving certain values to the as initializers, then as in the single dimensional array, the other values will be set to 0. So, by default, if some of the values are missing in the initialization, then those will be automatically set to 0. So, as you see, we have a 2-dimensional array called table, which is of data type integer, which consists of 2 rows and 3 columns. And here, as I told you, if we are putting that again in a flower parenthesis like this inside, it means that this is the first row element, and followed with another element like this, it would be the second row elements. So, what are the values that would be initialized to the matrix? Can you guess? Here you would see the initialization of this 2D array would be, since it contains 3 columns, but we have given just 2 column values over here, the third column in the first row would be set to 0 and the second row has only one value, that is the second row first column value would be 2 and the rest of the elements, that is the second row second element and the third element automatically would be set to 0. We will just execute this and show it as a simple program to see to check the output. Now, here is again another variation where we are not specifying both the subscripts. This is a special case where we are specifying or we are providing the complete initializers over here. So, we have the first row with 0 and the second row with 1, where this matrix is of order 2 cross 3. So, here even though we have not specified how many rows it has, since we have all the initializers set over here, by default the system is going to take it as a 2 cross 3 matrix and assign the first row elements all to 0 and the second row elements all to 1. And the implementation of the array stores all the elements in a single contiguous memory locations. So, as we saw in a single dimensional array, the array elements are going to be placed in a sequential manner in the memory locations. So, as the 2-dimensional array elements too. So, they are going to be put sequentially in the memory locations. So, here when we have matrix 1 comma 1 and matrix 1 comma 2, it is going to compare the rightmost index, that is 1 and 2. So, 1 happens to be a number which is less or which has to come before this element. So, this would be allocated first and then this. Just take a look at this picture where we have a two-dimensional array called matrix. The values of this matrix array, in case it is a 2 cross 3 matrix, you have 10, 12, 14 in the first row, and on the second row you have 20, 24 and 28. So, let us see how these elements would be allocated on the memory. Since it is a contiguous memory allocation, suppose the first element, that is matrix 0, 0 is allocated in a memory location, say 1200 for example, then it would be allocated on this location. So, the next element, that is the 12, would be allocated at location 1202. As I told you, it all depends on the data type of the elements. Since we have considered it as integer and we know integer occupies just 2 bytes of memory locations. So, here it is 1200 and 1201 would be for element 10. So, the second element 12 is being allocated at location 1202. And the third element, which happens to be the first row element itself, is going to be allocated next. So, 14 comes at 1204. So, as you see, all the first row elements have been allocated with the memory locations. Now, it takes the allocations for the second row elements. So, at the next subsequent location, that is 1206, 20 is allocated, then comes 24, then 28 and so on. So, that way the memory allocation for a two-dimensional array is going to be performed in the row wise. The two-dimensional arrays work well with the for loops, as also the single dimensional arrays. Whenever we need to deal with the array elements, either we want to input the values for the array or output the values from the array or process the elements of the array, we always make use of the for loop because it is the easiest loop statement that we could use. But in case of the two-dimensional array, having just one single for loop is not just sufficient. So, that is why we make use of a nested loop for the two-dimensional array. Why is that? Because we need to handle both the rows and columns. So, you just look into this example where we have initialize the values of the row and column to be 3 and 4. So, we are talking about a 3 cross 4 array, that is matrix, and we have also initialized the values for the entire array, and that array we are calling as VALS. So, we happen to have these values for our array, that is 3 cross 4 array. And now, we are just trying to output the values of this whatever has been initialized. So, we take upon first the row elements. So, as I told you, a two-dimensional array or a multi-dimensional array can be told as a set of single dimensional arrays. So, that is what you are seeing. Each row element we can talk as one list of array. So, here you could have 3 list of arrays over here. Okay, so that is why we have 2 for loops, one for loop to deal with the rows and the other for loop to deal with each column in that particular row. So, that is why we have for int row is equal to 0, we are talking about the 0th location, 0th row or the first row. and we are saying int column is equal to 0, column less than num column plus plus. So, it happens to be when you have a nested loop, the inner loop is going to be executed first exhaustively, and then we are going to come back to the outer loop. So, here we are printing the values of all the first row elements, and then after this has been exhausted, that is num call, that is this termination condition has been met, we again get back to the outer loop, increment the value of row. So, row becomes 1 over here, and we check the condition is still not met, that is it is less, it is true. So, we again carry on with the second row elements, saying from column 0 to 3. We will just execute this program and just see the output whatever we get. So, the final output as expected, that is of this particular array what we have through this program, would appear as follows. We will just look into some of the examples first, simpler examples. So, as I told you, while we were dealing with initialization of the array elements, suppose we give such an initialization for the array called table, that is 2 cross 3 matrix, and we have within the outer brace another brace, which means to say that I am talking about the first row elements over here. So, in the first row you will have the values 1, 2. And since it is 3 columns, the third column element has not been given, so it has to be set to 0. And this we are talking about the second row element. Though we have not enclosed it within a flower brace, it could be taken as the second row element. And we have assigned only one value for the second row element. So, the rest of the elements have to be set to 0. So, after initializing the array such as this, we are trying to print the array. So, to print the array, as I told you, I need to put that in a matrix form. So, the matrix has to have different rows and different columns. So, as we are talking about the 2 cross 3 array, we have to have 2 rows and then 3 columns. So, that is why we take the initial condition for the row to be 0, that is the first row, and then the final termination condition to be less than 2. So, it could be only 2 rows, 0 and 1, and the columns, as we have 3 columns over here, it could be 0, 1 and 2. So, your final condition could be column less than 3. So, within this inner loop, we are printing the matrix elements, and each time I print the matrix element, I need to separate that. So, I give a /t over here, that is the tab character, and I print the element over here, and at the end, that is when all the row elements, that is first row elements have been printed, I need to shift to the second row. So, at the end of this for loop, I give a printf/n, that is a new line character, so that to enter to the next line. And again I go back to the outer for loop, which means to say that I am talking about the second row elements. So, let us execute this program and find out what the output would look like. So, there you see you have a 2 cross 3 matrix, wherein the first 2 elements in the first row are 1 and 2, and the third element has not been specified, so it has taken as a 0. And then in the second row I have just specified only one value over here, that is 2. So you have 2 as the second row first element, and the other two elements have again initialized to 0. Here is another example, again talking about the initialization of the two-dimensional array. As you see, we have an array called val, which consists of totally 12 elements, that is, it is a 3 cross 4 matrix, 3 rows and 4 columns, and we have taken the first row elements to be such as this, that is 8, 16 and 9. Actually this matrix consists of 4 columns, but here in the first row we have just given 3 column elements, and the fourth column element has not been specified. So what would be your first row fourth element's value? Would it be a 0 or would it be a 3? And here, so that is one question we need to answer. And next we have 3, 15, 27 and 6, 14 and 25. Again, as we have put them in separate lines, does that mean to say that our second row elements are these and the third row elements are these? Does it mean that or something else? So the same output statements what we had done before we have done. So let us execute this program and see what the output would be. So here, as you see, 8, 16 and 9 are the first row elements. So we have in the first row 8, 16 and 9. And as I told you, we have not given the fourth element inside this parenthesis. So it has been set to 0 by default. And the second row elements has been taken as 3, 15, 27 and 6. So all the 4 elements have been taken over here. And then on the third row you have 14 and 25 less 2 element value we have given here. So that is why they have been taken as 0. Now I will just move the 6 to the next line. And let us see whether this makes any change in our output. Has it changed? Not exactly. See, I have specified it in the matrix form, the initialization, wherein I have given 8, 16 and 9 within a brace, which means to say that it always belongs to one row element. So since I have given that first, so that is the first row elements. Since it contains 4 columns, that the fourth element has been taken as 0, that is right. And then when you come to this, that is 3, 15 and 27, 6, 14 and 25, it really seems to us saying that these are the second row elements and these are the third row elements. But for the system, it has taken as any 4 values has been taken, that is these 4 values 3, 15, 27 and 6 have been taken as the second row elements, and the rest 2 elements have been shifted to the third row. So actually the positions of the values given in the program do not make much difference. Only thing, if you have enclosed them within the flower braces like this, that actually makes your difference, that is differentiating between the row elements. Now let us go into a more complicated program, that is, say for example, given a matrix we need to print the transpose of the matrix. What is a transpose of a matrix? It is nothing but the rows and columns are going to be interchanged. Say for example, you have been given a 2 cross 3 matrix, then you end up with a 3 cross 2 matrix as its transpose, and all the array elements are shifted likewise. So, for that a program to print the transpose of a matrix, wherein we have initialized the values for the matrix, that is, we are not inputting the values, we have already initialized them in as an initializers. So, we are just taking those array elements and printing that in an original manner and then the transpose of that particular matrix. So, here the first part of this program is going to take these values and print them in a given matrix form, and then we are going to convert that matrix into its transpose. So, as I told you, the rows and columns need to be exchanged. So, here we have taken the row. In the transpose of the matrix, we are considering the column over here. So, the rows and columns are going to be interchanged, and in the same manner the values, that is the array elements, are also going to be interchanged. Look at the output. We have the array, that is a 3 cross 4 matrix, and after this procedure is being done, that is, we are interchanging the rows and columns in this manner. I am putting all the row elements as the column elements, and so as you see, you have 4 columns, and here we end up with 4 rows. So, that is a example to print the transpose of a matrix. And what we need to do in case we need to find the sum of two matrices or addition of two matrices. So, in case of addition, the algorithm would be such as this. We have two matrices, that is A and B, and what we need to do is the first element of matrix A is going to be added with the first element of matrix B. So, both the subscripts I and J remains to be the same in both the arrays. So, we add these elements and put it into our resultant matrix, which is called as the C. So, for that, say we have the matrix addition program. Where we have two matrices that have been defined with a 10 cross 10, that is a maximum size. So, A, B are the two input matrices that we are going to add, and we are going to place the sum of these two matrices into the third matrix called C. So, for that we are going to accept what are the maximum number of rows and columns of these matrices. The rule for the matrix addition may be that the order of both these matrices would be the same. So, here if I enter the order, that is the number of rows and columns for one particular matrix, I would be taking it for both my matrices A and B. So, as you see, we are not initializing any value to the two-dimensional array, but instead we are accepting the values from the user. So, in order to accept the values from the user too, since we have to put them in a two dimension, we are going to make use of the nested for loop. So, after accepting the order of the matrix, I need to accept the matrix elements. So, by using these two for loops, that is I and j, where I represents the row and j represents the column, I am going to accept the values for the array by saying A of I and j. So, I is the outer loop. I am accepting all the first row elements by changing j every time, and then I change the row element, that is the second row, the third row, etc. So, we have accepted the first array elements, and then through these codes we are accepting the second row second array elements, that is the B array. And now in this module we are trying to add the array elements from of the first and the second array. So, as I told you, the sum of two arrays are going to be the first element of the first array plus the first element of the second array, that is 0, 0 of A and 0, 0 of B is going to be added and put into the resultant array called C as the 0, 0 element itself. So, it is much easier for us to deal with. So, we make use of the same for loops I and j, and we are using the same subscripts all through. So, I am talking about, when I am talking about 0, 0, it is always A of 0, 0, B of 0, 0 and C of 0, 0, the first element, that is the first row, first element. It goes on continuing with the first row, second element, this first row, third element, etc. So, at the end, I am trying to print whatever has been summed up over there, again by using the same nested for loops, and the way in which why we are specifying the /t and /n, as I told you earlier, would be to print those array elements in a matrix form. So, let us execute this program and find the result. So, the number of rows for the matrix, if I enter it as 2 and number of columns as 3. So, it is a 2 cross 3 array, which means that I need to enter 6 elements for each array. So, it is asking for the first element of the first array. I keep entering the values. So, there we have the first row of the first array has all ones, and the first row of the second array also have ones. So, the sum of them is going to be 1 plus 1, 1 plus 1 for all the elements. So, your final resultant matrix would have a 2 as the first row elements. The same thing repeats for the second row of the first array and the second row of the second array, that is which has 2 respectively. So, the value of it is going to be 4. So, as you see, this particular module in the program is meant for the matrix addition, the rest of which, that is one module to input the value for the array, that is the input the value or values for the first array and the second array, and finally to print the output of the resultant array. So, as you see, the program seems to be very lengthy, but the content of this program is repeatedly been performing. So, it is a much easier program than we expect. Finally, winding up, we will just look into the common programming errors that we usually make while we are writing the program or while we are executing the programs. Addressing the indices would be out of bounds, that is the lower bound or the upper bound if it has crossed. Then the C compiler is never going to check out with these errors. So, either it would be resulting in a runtime crash or in a logical error. So, it is not going to indicate us with a syntax error. So, the programmer generally would get confused because of this. And then we need to be careful, especially when we are using expressions to compute the indices. That is, generally the indexes would be taken as the integer values. But sometimes this index could be also expressed by making use of the expressions which could be evaluated to an integer. So, while such expressions are used as indices, care must be taken. And then always remember that indexing will start with 0 and not 1. So, our array allocation, either it is a single dimensional or a two dimensional, always start with a 0 in case of 1D and 0 0 in case of 2D. And so occasionally, like the student would forget to cover the subscript by the square bracket such as this. So, a single dimensional array should be having the subscript enclosed within a square bracket, a single square bracket such as this, or a two dimensional array should be given the subscripts with two squares naming the row and the column. Thank you.